Alright, this is Mr. Sitta. I'm going to go through the Chapter 7 review on periodic properties. Okay. Two things you probably want to have. You want to fill in a blank list of periodic trends, and you definitely want to have a periodic table out. Okay. Number one, who is credited with the concept of atomic numbers? Henry Moseley is an Englishman who gets the credit for the modern periodic table. Mendeleev only knew about atomic masses, and Mendeleev actually already put it in order, but he didn't know anything about protons, so Moseley's your man. Okay. We want very similar chemical properties. I'm looking for the same group: oxygen, sulfur, and selenium. When you actually take the test, I'm going to have the atomic numbers on there so you can find them quickly. But oxygen, sulfur, and selenium, if you're in the same group, you have similar chemical properties. Elements in the modern version of the table are arranged in order of increasing, and that would be Moseley, atomic numbers, not weight. Which is the smallest orbital? And I'm looking at the 1s. The 1s orbital that's the smallest will be the one with the most nuclear pull, the most protons. So every one of these atoms have a 1s, but the smallest one is going to be iodine because it's got 53 protons. Okay, electrons in the 1s are much closer to the nucleus in argon than in helium. And again, this is the same type of question. Because of your nuclear charge. That's your Z effective. Of the following, which gets the correct order for radius? Now, they should all be in the same period. And the largest would be sodium, so I'll start looking at D right away. Sodium, magnesium, silicon, phosphorus, it looks like D. Sodium, magnesium, silicon, silicon, phosphorus, and sulfur. Okay. The atomic radius of main group elements generally increases down a group. Why? That would be your principal quantum number of the valence orbitals increases. We're looking at N, principal quantum number. Nothing to do with nuclear charge because Z effective up and down is constant. And again, everything else is mentioning nuclear charge, and nuclear charge would be a constant up and down, and that's what we have to know. We have to know our periodic trends. Okay, which one has the largest radius? Now is when you want to have a pen and a pencil and a periodic table you can write on. You got oxygen, you got fluorine, sulfur is larger than oxygen. I'm looking for lower left in this whole list. Chlorine and neon. Lower left is sulfur. So large left, large down. Lower left. Which would be the smallest? Upper right. Smallest would be fluorine. Okay. Who's got the largest radius? And let's see. I got strontium and calcium. And again, I'm looking, largest radius would be lower left. Potassium and rubidium looks like the winner. And Y is over here, so rubidium. I just have to know that size is up as you go to left and up as you go down the left, right? Okay. Who's got the largest first ionization energy? I'm looking to the right and I'm looking up. Okay, so I got sodium, aluminum, selenium is over here, chlorine, and bromine. Chlorine is the most to the right and the most up. Highest effective and the smallest size. That's the reason. If you were taking an AP class or the AP test, they're not going to allow you to say to the, oh, why is it smaller? They're going to, if you said, you know, if they ask you a question, why does it have a large ionization radius? You can't say because it's to the right and because it's up. You actually have to say the actual reasons. The reasons why chlorine has the highest ionization energy is to the right, it has the highest Z effective, +7, and all the way up it's got the smallest size. And then you could explain Coulomb's law, how size and charge affect the attraction for that electron. Okay, things you got to do. Okay, got to watch my time because I don't want to go over 24 minutes. Okay, who's got the lowest first ionization energies? The lowest energy would be to the left, so I'm looking at alkali metals. Increasing ionization energy. This is a tricky question because if you graph it, there's those two anomalies where you got the half full and the full. If I ask you this question on the test, I'm just going to ask you, give me the order that they are. Okay, so I would expect that it would be lithium, then beryllium. So B through D are all looking good. Then boron, and then after boron it should be carbon, nitrogen, and oxygen. And it looks to me like D would be the correct order. So I would say D is the correct order, but in actuality, if you really want to get technical, beryllium's ionization energy is higher than boron. It's an anomaly. So it's actually that boron comes next, then beryllium, and then CNO. N ends up being higher than O because it's half full. So the technical correct answer to this question, let's see, beryllium, carbon, and then it's N. N is at the end. So it's actually, these two are switched and these two are switched. The answer is actually A, but only because exceptions, and I'm not going to ask you that on a test, so don't sweat it. Okay, who's got the largest second ionization energy? Now, all the alkalis have a low first, but if you take away a second electron, suddenly you're taking away from the noble gas core closer to the nucleus, more Z effective, so it would actually be sodium. And there's a chart I could show you. This is what they mean. Sodium has a low first and then boom, a high second. You're not going to see this chart, but it's that it jumps up because suddenly you're taking away inner core electrons and they jump way up. Probably wouldn't ask you that question on COVID-19. If I'm going to ask you for the first ionization energy of aluminum, I don't want to look at any of these. I'm just going to say aluminum, okay? And ionization energy is taking away one electron, so it becomes aluminum with the +1. Now, when you take particles apart, that's endothermic, so this would be plus heat. Your delta H for this would be positive, it would be endothermic. So whenever you're taking particles apart, endothermic. When particles come together, exothermic, it releases heat. So what do we have here? Looks like D. Just matching that up. Doesn't mention heat in there. Who's got, now, this is a question I wouldn't ask you. The most negative electron affinity, I would ask you the highest electronegativity. This is kind of an old test I used to ask about affinities. The reason I got rid of affinity is the most negative is the highest, and that always bugs people. I'm looking for the most right. So I would say halogens, group 17. They have the most affinity for an electron, and that's why halogens as a whole become -1. Fluorine, fluoride, bromide, iodide. Why? Because they have a high Z effective of +7. Okay. The alkalis have a low Z effective, so a low on his electron affinity. And really that one we would be asking electronegativity. Who's the most negative electron affinity? Again, this will be to the right and up. And I'm looking at chlorine, I do believe, is the most right and up. More to the right than sulfur and more up than all these. Chlorine. As you go across a period, left to right, the atomic radius decreases. Get rid of those two. The electron affinity becomes increasingly negative. So I can get rid of that. It looks like D. And then for as you move to the right, it says across left to right, your Firestone ionization energy also increases. So it's decrease, increase, increase. Chlorine is more apt to exist as an ion than sodium. Okay, this is because chlorine has greater electron affinity. Ionization energy is metals, and so I would replace that with electronegativity today. Okay. Of the elements below, who's the most metallic? The most metallic would be left and down, and it looks to me like cesium's on this list, right there. You got cesium, sodium, barium, and calcium, and the most down and left is cesium of the group. Who's the most metallic? Again, here's sodium, here's magnesium. It's going to be sodium over magnesium. Aluminum's to the right. Nope. K. Yep. K is more metallic than them, so K. I don't know what AV is. I don't even know if there is an AV. Okay. All right. Check my time. Okay, I think I can get this done. So I'm going to just let it run. Which element? Most of the elements on the periodic table are metals. Over here on your table, everything's mainly a metal. That's nonmetals. Only two liquids. Okay, between two elements, what's the greatest metallic difference? So I want the metal to be most left and lowest. So rubidium is over lithium, so I'm going for rubidium. Okay, and then I want to go to the most right and up. You got iodine and oxygen. I would pick oxygen. Looks like rubidium and oxygen. Okay. Kind of want the farthest away from each other. Okay. But iodine is less electronegative, so oxygen over iodine. What's always produced when an active metal reacts with water? Hydrogen gas. You should know that from your barking dog lab. We put active metals and acids and we were blowing up hydrogen gas. Which of the following is an active metal? Calcium. Active metals are alkaline earth and alkali. The more to the left and the more down, the more active you are. Okay. Somehow I feel I'm out of order, but I'm not. Okay. Okay. All right. The element is more reactive than okay, this is a good one. Okay. I'm more reactive to lithium, so I'm lower. And magnesium, so I'm more to the left, but less reactive, and so I'm greater than potassium, and right in the middle of all that is sodium. So it's left and lower from all the rest, but higher than potassium. Who's the least reactive? On this chart, I would say the most right and the most up looks like magnesium to me. And again, we got to put these things in acids, so we saw how a lot of them reacted. Red or crimson color in fireworks. Wow. I think we could get away with saying calcium is brick red, lithium's like a crimson, and strontium's kind of a reddish orange. So I would say calcium, strontium, or lithium, or strontium alone will give you red. So I could say either D or C, being right. Don't sweat it. Maybe you can look that up in the book and tell me. Alkali metals tend to be more reactive than alkaline earth because alkalis have lower ionization energies to the left. Oxides of active metals combine with water to produce, remember, metals produce metal hydroxides, otherwise known as bases. Okay. The alkali metal forms with chlorine with the formula So if you have an alkaline metal, it's going to be a +1. Chlorine's a -1. So your ratio is going to be 1 to 1. So it would be D. Okay. Just knowing the charges of active metals. Putting some stuff together here, like formulas and things. All the following are ionic compounds. Okay, metal, 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 winner, winner, chicken dinner. Silicon oxide is not an ionic compound. Kind of unusual, it's molecular. Well, actually, it's a molecular network crystal. When you have SiO2, it's glass or sand, and it's almost like a polymer. The units just keep repeating with a 2 to 1 ratio of SiO2. So that's a covalent network crystal that we learned in chapter 11. Element X reacts with chlorine. So I got X reacting with chlorine. Okay, it forms XCl2. Well, if there's a 2 here, then Cl is a -1, so the X must have a +2 charge. Now, it must be an alkaline metal, so then it asks me which one it is. It's an alkaline earth metal. The only character on there is calcium, which is an alkaline earth metal. Which is a solid at room temperature? I kind of asked you about iodine before. Iodine at room temperature is a solid. Bromine's a liquid, fluorine and chlorine are gases, hydrogen's a gas. What's a unique element and doesn't belong to any family? Hydrogen. Hydrogen's not an alkali, so what makes it that way? I consider the hydrogen to be a metalloid. Okay. We see it as a non-metal. On our planet, we tend to think of it as a non-metal. If you were in Jupiter and Saturn, hydrogen is actually at such a pressure, okay, and temperature, that on different planets, hydrogen can be a metal, and it would have a luster, and it would be magnetic. And we know that because it gives Jupiter and Saturn magnetism. Okay, some of your gas giants have a solid hydrogen core. The most common ion of sulfur, fresh fish. Sulfur is a -2. The carbonate of which alkali metal is used to treat manic depression illness? There was a guy that had a band named Nirvana, Kurt Cobain. He sang about lithium, because lithium is used to treat manic depression. By the way, lithium used to be in 7-Up. So 7-Up makes you feel up, gets you out of your depression. When they found out that it affected your brain chemistry, the FDA made them take lithium out of their formula for 7-Up. And in the 1800s, that drink was called Bid-Lithiated Lemon Lime Drink. That was actually the name of 7-Up before it became 7-Up. Who's got the physical properties closest to calcium? The one that's in the same group, and it looks like strontium. Okay. Who's got the largest first ionization energy? To the right and up, not including the noble gases? Fluorine. That does it. 38 questions. It's going to be short questions, quick questions, but you can do a Zoom meeting with me if you have any questions on anything you don't understand. That concludes Chapter 7.